I'll first start by saying that the title is a bit of a loaded statement. Part of the strategy of getting a talk accepted is to give kind of a crazy title talk and hoping that it stands out. And then I am burdened with having to defend the title talk during the talk. I do think that there is some truth in it though, and hopefully I'm able to at least get some people on my side for this. So, out of curiosity, first of all, are there any people that are actively developing their day job in Elixir in the room? No? Is anybody unfamiliar with Elixir? They're just like, what is that? I came in here to learn more about it. Okay, all right, so about half the room is familiar with Elixir, the other half is unfamiliar. That's a good mix. All right, as I was introduced, I'm the CEO of DockYard. We are a software consultancy, and we do full stack application development. So if your company has a project that they want to ship out to a company that has a very good track record of delivering on time and on budget application builds, you should please consider us. So why the insanity? I'm going to try to define the insanity in today's terms as the amount of demand that's being put upon engineering teams to deliver today's problems. We're starting to have requirements that may have a mix of distributed systems, mitigating downtime, self-healing systems, real-time, etc. And these are difficult problems to solve for the tools that we've been using for the past few years. On top of that, your systems must be fast, and they also must scale to ever-increasing demand. As more of the world gets turned on and mobile devices getting faster internet connections, there's going to be more demand put upon your applications that are coming from a global demand now. But for the most part, as I said, we're using yesterday's tools. But the way that we reach for new ideas, like entrepreneurs or managers or teams or product developers in general, is we've taken like the older problems, which was how do I build a dynamic running application, and we've kind of boiled it down to git push Heroku, right? So that problem is solved, it's hyper optimized, and now that the costs of building those out are so nominal, now the problems that felt unreachable before are now problems that are within our reach. But we're going to need new tools to build this out. So before I get into the Elixir stuff, I want to take a step back 30 years and talk about the underlying technology of Elixir. And it's Erlang. So for those of you that are unfamiliar with Erlang, it was, or rather it is, a technology that was built by Ericsson, the telecommunications company out of Sweden. It was like mid-'80s, late '80s when it was built. I think it's really 28, 29 years ago, not exactly around 30. But it was meant to handle global telecommunication systems. So some of the requirements of it are like almost zero downtime, right? So if you have a telecommunication system worldwide, you can't really deal with downtime. You have to have fallbacks, you have to have fail-safes, you have to have systems that can monitor other systems to ensure that they're going to be bounced properly. You have hot code loading. So think of your phone, right? When's the last time you received an update from your provider saying, we're taking down the network for an update? It doesn't happen. So in Erlang, you can actually have the system in production, and you can push code deltas up without taking the production server down, and it will absorb these code deltas and incorporate them into the runtime that's currently live in production. These are some really incredible and they feel like cutting edge type technologies today that have been around for a long time. So if that's the case, if Erlang's so awesome, then why aren't we using Erlang? I mean, there's a couple different potential answers for this. A lot of them are opinion-based, but this is my opinion on why we're not using Erlang. It's the syntax. So, and it's, again, it's one of the reasons, but Erlang at the time was based upon Prolog syntax, which has a, I think the way to describe it is like a sentence-like like programming structure where each line is delimited by a comma, the statement is finished with a period, but it kind of grew over time organically, and so something that should feel simple ends up looking difficult for those that are used to more modern syntaxes in their languages. I personally came up learning C, C++, assembler through the Microsoft assembler, and then I jumped over to Ruby and I've been doing JavaScript. So I don't want to take a step back syntactically. Like if I'm working in my day job, I'm working with a language, I want to use something that I enjoy. It feels like a bit of a cop-out. I think some people that perhaps have been programming for a long time, they may be thinking like, oh, that's a stupid reason. But the proof is there in that Erlang hasn't reached mass adoption, despite its incredible power, despite how well its solutions apply to the current problems we're dealing with today on the web. And this is where Elixir had an opportunity. So this is Joe Armstrong. This is a much younger picture of Joe Armstrong. So Joe, after Elixir, I forget what version, but early on in its inception, he, on his personal blog, he wrote I have a link down at the bottom. But anyway, it's just a blog post, and he's like, I'm going to check out this Elixir thing. And one of the quotes in there, he recognized the syntactic issue of Erlang and what Elixir brings to the table here. So he said, quote, what Elixir brings to the table is a complete different surface syntax inspired by Ruby, what you might call a non-scary, quote-unquote, syntax and a load of extra goodies. Elixir, the little bit of history of Elixir is that it is created by a programmer, his name is Jose Valim, and he was, until maybe 2 years ago, somewhere around there, on the Ruby on Rails core team. He came up learning Ruby, got into the Rails core team, was probably one of the top developers on the core team, but while he was working on Rails, he saw a lot of the problems that the Rails core team was trying to solve, especially around concurrency, and how difficult it was to solve these problems with Ruby as the language that they were limited to. So I'm not trying to talk down to Ruby at all. Ruby is an awesome language, and it gave me a career. I was not doing anything after college, and then I got into Ruby, and I had about a 10-year career working in Ruby. So specifically Rails, I'm very thankful for that technology. But we can't use the same technologies forever. And as I said earlier, as the problems become more complex, we need better tools to solve those. So in kind of a bit of research on how best he can solve these concurrency issues within Rails, Jose went back, started reading a lot of papers. He always had an interest in Erlang, and he decided, oh, screw it, I'm going to try to write a syntax on top of the Erlang virtual machine. The first pass was a bit of an object-oriented application, object-oriented syntax that would compile to the Erlang functional bytecode. That didn't work. He then backed up and said, look, do I have to try to create a whole new language, or can I just kind of keep this like this light sugar on top of Erlang? And that's where he really found a good place to excel with Elixir. So Elixir itself, it is a language, but it is, it's really a surface level language that doesn't do much on its own beyond once it compiles to Erlang. It allows Erlang's virtual machine to handle all that stuff. So when you compare it to other languages like Scala, or other, like the JVM has a whole bunch of languages that run on its virtual machine. Elixir is probably less involved with the nuts and bolts under the hood than some of those other languages are. Like Elixir's probably more complex part of the source code is really in its parser and tokenizer. Once you get past that, a lot of the language itself is actually written in Elixir. So if you were to check out the Elixir GitHub repo, you would see, I think it's something like 80, easily north of 80% of the actual repository is in Elixir itself. So simple statements that you may be considered to be like compiler keywords, like if statements, are actually just Elixir code that you can write your own if statement through a macro system that I'll be talking about a little bit later. But anyway, so let's see what some of the things that Elixir inherited from Erlang. So as I said, it's a battle-tested 30-year-old technology. If you're in here like wondering, like, is this a good technology for my company? So nowadays, we're kind of overwhelmed with the number of new languages, new frameworks that are coming out almost on a daily basis. Like if you're reading Hacker News, it's the running joke, like what's the new JavaScript framework this week? And we kind of have this sense of anxiety, like, should I be on the latest and greatest thing all the time? I think from a hiring perspective, sometimes that may be easier because people like to work with and tinker with the newest thing. But anybody that's been a manager in a technology company for any period of time can tell you that, well, that may be easier to hire. When that person leaves your company, I mean, the technical debt that they leave behind is very, very expensive. So in my career, I've tended to actually look back and try to look at the things that have worked from a technology perspective and how can we leverage that in the future. And Erlang to me makes a lot of sense here. So it's not like an unproven new language that we're taking on this significant risk into our organization. This is something that is being used on a global scale by multi-billion-dollar corporations right now. When it comes to managing distributed systems, there is a library within, sorry, that should be bold, the GenServer. There's a library within Erlang called GenServer. And we will see code examples on how easy it is to write a GenServer, how easy it is to work with doing asynchronous and concurrent computing. We can get self-healing systems through supervisors. So what do I mean by self-healing? A self-healing system is one that recognizes when something goes wrong and puts us back into a good state. And the supervisor pattern within Erlang is a very simple idea that ends up being incredibly powerful. And if you've done any type of programming where you're having to predict how can this system go wrong and having to basically do a lot of error catching and if statements or case statements, I think that the supervisor pattern is going to be an eye-opener for you. It's based upon one simple principle, which I'll get to on those slides. And it can quickly scale to meet tomorrow's demands. And finally, a nice kind of syntactic thing is pattern matching, which I will show. So new for Elixir. So these are all those things from Erlang is what Elixir inherits, and these are the things that Elixir adds on top of it. So it adds a clean, familiar syntax. If you've worked in Python, if you've worked in Ruby, if you've worked in C#, there's all different aspects of those languages that Jose looked. And so he looked at the kind of the landscape and said, like, okay, I really like Ruby syntax, but there's some things that are wrong with it, some things I wouldn't have done myself. He took all the best things that he thought were the best things from different languages and brought them into Elixir for the syntax. As a mature tooling system, so for a language that just hit 1.0 in the past year and a half, or maybe closer to 2 years at this point, it launched with a task running tool called Mix. And Mix brings in debugging tools, linting tools, documentation tools, dependency installation and dependency resolution tools, generating tools. So all these things are already built into the language. This isn't a separate library that you have to bring in. This is something that is part of the core language that is made part of it. Built-in unit testing, again, through the language, through it's called XUnit. Metaprogramming. So metaprogramming to you in different language may be, maybe considered dynamic programming, right? Like how do I declare a class dynamically, or how do I define a method dynamically? Metaprogramming in Elixir is actually a lot more deeper than that. So it actually tries to do away with the idea of dynamic code creation, and it brings in this idea that what you're generating is only being generated at build time. So I forgot to mention, Elixir is a compiled language. It's not a it's not a language that that is at a runtime type language. So during compile time, the macros that you're doing metaprogramming with will actually get compiled down to bytecode. And you can do language extension features at this point. So when I was mentioning the if statement and things like that earlier, those are all done through the macro system, the metaprogramming system in Elixir. Built-in documentation, so documentation is a first-class citizen inside Elixir. In fact, it's not just documentation itself, but there are this concept called doc tests, which I wasn't able to get into my slides, but doc tests will actually allow you to write small little unit tests inside your documentation, and so that when you run your test suite, it will run the doc tests as well to ensure that your documentation is actually showing the proper working code, which is really important. So Jose wanted to make sure that documentation was something that was really first and foremost in the mind of Elixir developers. Pipes, which is another syntactic sugar. And finally, Phoenix, which I won't get to today, but Phoenix is a web framework that is probably, if you've heard Elixir, that's probably the reason why you've heard of Elixir. So let's look at pattern matching. So this is a simple statement, A equals 1. But we have to consider that in Elixir, we're not doing what is done in other languages. So in other languages, you'd be looking at this and saying, this is an assignment. In Elixir, it's not an assignment. It can feel like an assignment because after you've done this, the A variable has the value of 1. But what you're saying is that A is equal to 1. So you have to look at it like an equation, the left-hand side and the right-hand side of the equation operator. Because what you can also do is that after you've said A is equal to 1, you can say that 1 is equal to A. Both of these are valid statements, but only after you've done the first one. So this is the basis of pattern matching. You're saying that some variable is equal to some value. This is also a valid statement. So these are not arrays, these are lists. There's no concept of arrays in Elixir, but lists have mostly the same purpose. There's another type called a tuple that can also act probably more similarly to a list, to an array. But anyway, in this case, I mean, these are exactly the same values, right? These have equality. You can go into the Elixir IEX, which is the kind of the REPL for Elixir, and you can type this in, and it would be a truthy statement. So you can do this. What I'm saying now is that a list with a variable A in it is equal to a list with a value of 1, which means that A is equal to the value of 1. So if I were to unwrap the A variable from the list, the value of A would be a list, 1 wrapped in a list. But in this case, we're pattern matching. We're saying that based upon the pattern on the right-hand side, we have a pattern on the left-hand side that matches it, but we're saying that this variable matches the particular value that pattern matches on the right-hand side. We can get more complex. So here's a two-dimensional list. And of course, all the values, we're able to capture those. And finally, we can get, we can go to any depth. So we can say that the third element in here is also a list. And if the third element on the right-hand side is also a list, we properly pattern match upon that, and we capture the value inside. So what this ends up doing is that this kind of quick primer right here, it will prepare you for writing functions within Elixir. So typically when you're in other languages, you only get to write like one function definition. There's plenty of other languages you can write multiple function definitions, based upon the arity of the arguments. But in Elixir, you can write multiple function definitions with the same arity, but have different patterns within that arity. So here I've declared two functions, foo, and I put values directly inside the function arguments, and this is completely valid syntax. If I call foo and I pass the number 2 to it, it's going to call the second foo function because it looks at the values there and just matches it. It says, okay, this pattern matches this, these values match this pattern. If I were to have a foo with just a named variable inside of it, then based upon the order that it is defined in, it will match. So it kind of does a first wins. So if I were to have like foo and then bar up above foo1, that would be a greedy matcher, and that one would always win because it's the order in which it tries it. But if I put it last, then if I passed foo3, it would pass to that one, and then the variable in the argument would have that value. Elixir is smart enough that if you were to put the greedy matcher above a function that otherwise should match, it will warn you when you compile and say that this function on this line will always match, and then functions XYZ can never be matched. Oh, let me back up for a second. So this pattern ends up being really, really powerful because what it really does is it kind of breaks out branching logic, right? So you may have functions that you've written or methods that you've written in other languages where when you get passed into the function, now you have some like really nasty if statement in there to kind of break up the conditionals, or you may have to sacrifice on your function naming by basically creating a bunch of different function names that are naming things is hard in programming languages. What this ends up allowing you to do is doesn't so much obfuscate the conditional logic, but at least allows you to give a cleaner pattern for having branching in your code and having specialized function to handle things. Pipes allow you to clean up messes like this. So I'm super guilty of this in other languages. You may try to clean it up a little bit by doing something like this. So you take the innermost function, assign it to a variable, and you keep passing it down and down and down and down. Well, this is another feature that Elixir stole, so it's piping. And the way it works is that it takes the value that you're piping, and it will inject it as the first argument into the corresponding function. Is that me? No. So if the result of Baz taking the hello world value gets piped in as the first argument into bar, and the result of bar gets piped into the first argument of foo. The pattern that starts to create for you in your Elixir code is that you start to really write for composability, right? So a lot of your functions end up corresponding to this simple idea that the first argument should be the carry value. In fact, Elixir wraps a lot of the Erlang API, and it rewrites the argument order to try to ensure that the primary value being passed in is always the first argument to allow for easy function, to allow for easy function piping. The scalability. So that was all syntax, that was nice stuff, and there's a lot more really cool syntax in Elixir, but I'm limited on time. The Erlang VM, also known as the Beam. I do not recall what it stands for at the moment. So the Erlang VM is almost an operating system onto itself. Its primary purpose is to monitor and schedule its own processes. So if you're confused when I'm interchanging Erlang and Elixir, just let me know and I'll try to explain it a little bit more. But again, Erlang is the underlying system of Elixir. Elixir depends upon Erlang. And so a lot of this kind of low-level stuff are traits of Erlang, but Elixir gets everything. So in Erlang, you have the idea that it is a very concurrent language. So you can create very small and cheap processes very, very easily. And all those processes are monitored and scheduled by the Erlang VM. So in the same way that your operating system monitors and schedules operating system processes, Erlang VM monitors and schedules its own processes. So it will make sure that when these processes die, that the right error code is being reported. If the processes are kind of eating up a lot of system resources, it's probably distributing them within the system. And as I said, so it's distributing them. It can actually distribute them across all available CPU cores. This is a huge performance gain if you have anything that is fairly CPU intensive. And it happens automatically. So as long as you're running your application in a concurrent manner and using processes, then all the processes will get distributed across the available CPU cores to the Erlang VM. So one of the more popular deployment targets in general right now is Heroku. Everyone's wondering, deployment is still kind of a difficult answer to give something difficult to give a straight answer to in Elixir. It's a problem being solved, but we don't have an awesome deployment story yet. There's decent ones, but not awesome ones. And so the reason for that is you can do git push Heroku. But Heroku is not a good deployment target for Elixir. And the reason for that is because Heroku shards your CPUs. You can pay for a dedicated system where you're going to get a multi-core Heroku box, but then you're paying a lot of money. For me right now, I think it's better to go with like a Rackspace or a Linode or something like that. Something that you get those dedicated cores or at a better cost, and just deal with the deployment headaches for now. So the nice thing is that the Erlang processes are incredibly cheap compared to operating system processes. So each process is a little bit over a kilobyte, so you can spin up a ton of them. They spin up very, very fast and they die very, very quickly. And on top of that, each process carries its own garbage collector. So what this ends up meaning for you is that in other languages where you have a single thread or main thread and the garbage collection ends up happening, it may be a mark and sweep, it may be a generational garbage collector, but in any event, it still has to stop the world and do its work while it's collecting all the garbage. Now, if you take another language with a set number of objects and compare it to a Erlang or Elixir application with the same number of objects, these objects may be distributed across multiple processes. And if each process runs concurrently and has its own garbage collector, then the surface area in which it's actually exposed to for cleaning up its own garbage is very, very small. So that garbage collection process goes very, very fast. And on top of that, those other processes that aren't currently garbage collecting are still running. So this is where Erlang gets a ton of its speed from, because it's not blocked. Its main thread is not being blocked by any garbage collection, any one garbage collector rather. So a lot of the process kind of scaling within Erlang was evidenced through work that an employee of ours, Chris McCord, who created the Phoenix framework, was doing with WebSockets in Phoenix. So he was around like early 1.0 of Phoenix. Someone came into one of the channels or an IRC and said, hey, I tried to scale up to 60,000 concurrent connections and it started kind of bombing out on me. So Chris started poking with it, and after a week, he got it up to 2 million concurrent connections. And at that point, he figured this is good enough. And that's on one box. That is one box. It has a ton of memory, but it's one Rackspace box that was able to scale up to 2 million concurrent connections. These are not just dummy connections sitting there doing nothing. They were actually simulating real conversations, real message passing between each other. The latency for distributing a message across all 2 million WebSockets at that point was less than 2 seconds. So you can imagine that real-time communication system that is dealing with a lot of people. Like, think of Slack. Like, I can't imagine how much money Slack is paying in server power right now, because I know that some of their underlying tech is PHP. I don't know if that's part of their real-time side of things, but I know that is part of their stack. I would just be, it wouldn't surprise me if they were using Erlang in some way, but I don't know if they are. If they weren't, I can only imagine that something like this could really cut down on their costs. If you're doing anything that is a real-time messaging system, like, you immediately can start to see the benefits of this from a business perspective and how you really can bring down your overhead big time. So let's look at a case study specifically on one company that was able to have massive infrastructure savings by moving from one language over to Elixir. And it's Bleacher Report. So they had an 8-year-old Rails app, and here's the architecture of that Rails app. For anyone that's unfamiliar with Bleacher Report, it's a sports news website. So they do a lot of reporting, they have a lot of video, but on top of that, they also do a lot of push notifications, right? So a big thing in the sports news world is who pushes the sports news first. Prior to this, if you had like a CBS Sports and a ESPN and Yahoo Sports and whatever other applications on your phone, you have Bleacher Report on there, it would take sometimes up to a few minutes. Like if the Bleacher Report person plugs in the report, bang. It took a few minutes for you to receive that push notification. I'll tell you what it was afterwards. So they had 150 AWS instances supporting this application. Even at this point, their servers were jammed up with requests. So there were many times in which they were receiving too many requests and they can get the responses out. And this was, of course, a big problem. Their engineering teams were fairly large to support each of their apps, each of their own individual apps. Their main app was the 8-year-old Rails app. And so there's a lot of personnel overhead for each application. And they had multiple complex caching strategies. So caching is not an easy problem to solve, and getting something in place that works well can be expensive at times. So afterwards, this is after they moved over to Elixir and Phoenix, they had 1/5 the number of AWS instances. For one of their applications, they went from 20 servers down to 2, and the only reason they had 2 is because the second one was there for redundancy. Now they're averaging about 10 to 30 millisecond response times. The largest average spike is about 400 milliseconds, and they had one outlier spike of 800 milliseconds. These numbers are good as of 6 months ago, so I don't know if they've changed much, but Bleacher Report's been pretty vocal in their Elixir and Phoenix case studies, so I imagine they're still pretty similar. On top of that, they have about 1 engineer per application now. And if we have time, we'll get to why this is important and how this is possible. And they're also doing no caching. So other examples, I promised you the push notification thing. So Bleacher Report went from like 3 minutes to getting the push notifications down to within like 3 seconds. So all of their subscribers get a push notification almost immediately when the reporter actually publishes the article. So the business value back to Bleacher Report for this is that if you're competing with other applications on the phone to be the first one to publish an article, to get the push notification, you're competing with all these other applications to get people to push on your push notification and to bring you back to Bleacher Report so you can start getting eyeballs on ads. So it's very important to be the first one there. So Elixir, brought in significant business value for them almost immediately. Other examples, and these are more Erlang examples, but kind of demonstrates the scalability. WhatsApp is the classic example within Erlang. For those that may be unfamiliar with WhatsApp, it's a messaging system, right? So it has phone, text, but it's all over the internet. They're famous because Facebook bought them. I think it was Facebook, but they were bought for a lot of money. So they bought for like $17 billion or something like that, and they had an engineering team of less than 20 people. So they were able to build up something that scaled to billions of connections per minute with a very small team relatively. And because they were able to build something that scaled that high, the amount of return they got on that when they got bought out was significant. eJabbered is a pretty good example of an open source Erlang application if you want to check one out. Riot Games uses Erlang internally for their messaging system as well. League of Legends, that's what Riot Games makes. Okay, GenServers. All right. It worked. You had no idea how long it took me to get that right. Okay, so this is a simple GenServer. And what we're going to do is create a stack. So can't really point on my pointer, but I think this is actually the real kind of first comprehensive Elixir code I've showed you. But the idea here is that we have a module. Module is simply just a namespace. So we don't have classes. We don't have objects within Elixir. It's not object-oriented language. It's a functional programming language. But the namespace allows us to organize our functions in such a way so we don't have this one monolithic namespace where we have to avoid name collision on function names. But in any event, use GenServer allows us to bring in some functionality of the GenServer module. So now we get some code injected into our module automatically. And start link allows us to create the new process. In this case, our start link function is calling a GenServer start link function. The __ module is just a way to reference the GOTO Chicago.stack module. The state is going to be the starting state of the GenServer. So in this case, we're going to pass it in an empty list, and this is going to be our starting state. And then options we'll ignore for now. So there's 2 functions here, handle call and handle cast. Handle call allows us to, when you call a GenServer, it's a blocking request. And when you cast a GenServer, it's basically just a fire and forget request. So the handle call, we're using some pattern matching here, and we're going to say that on a pop request, you can ignore the second argument from for now. Just know that anything that starts with underscore is a argument that gets ignored by the compiler. If you have an argument that is not underscored and you don't use it, you get a warning saying that you have an unused argument. And then the syntax at the end there is a way for us to reference the parts of a list. So you have a head and tail, and head is going to be the first element and tail is the remainder of the list. So in this case, if we had 1, 2, 3, H would be 1, and then T would be 2 and 3. H would be a single value, the T would be a list. Handle cast, so we're pushing into the list at this point, and we want to, so we give it the request that we're pushing, and then we give it a value that we want to push onto it, and then T is the state. And so down at the bottom we have a reply, no reply rather, and we're basically prepending the head onto the stack. So the way we end up using it is that we can call start link. We pass it that initial state with an empty list, and we get back this reply. It says OK, and this is kind of semantics within Erlang for things that are going well. It's going to say OK. Some of the things that don't go well, we may get an error. But the second argument within the tuple is the second element rather is the PID. So similar to an operating system PID, this is going to be our reference back to this given process. So in this case, we're going to cast to the GenServer. So cast, again, is a fire and forget. So we pass to the PID because we need that unique identifier back to our GenServer process. And we're going to do the push. We're going to push in a hello onto the stack. And then finally, we make a blocking request because we're waiting for a response from the server. And we do call, and we pass to the PID because we need to reference the GenServer and call pop. That is GenServer in a nutshell. It's a very simple system that allows kind of abstracts a more complex system within Elixir. Each process has its own mailbox, and you can reference other processes and pass messages, and these messages can get processed. Do get processed synchronously. So you can build out something like GenServer on your own, but GenServer gives you this really nice kind of abstract layer for dealing with message passing. You can kind of think of it like a web server, right? So you have your web server instantiated, you give it a request, and it gives you a response. So supervisors, and the tree of the supervisor is the reason I have the tree there. So let's look back at our GenServer for a minute. So let's say we started it up again, and we did the push into it. Okay, that's great. But what if we gave it a request? What if we requested something that we didn't previously define? What we're going to end up getting is this error back, and the most important thing is the last word on the first sentence is terminating. So when an error occurs within our process, the process just dies out. And this brings us into one of the more important aspects and ideas within Erlang, which is called let it die. And as I was saying earlier, you may go through a lot of trouble trying to figure out what are the different ways in which my application can error out, and I should try to capture those errors and handle them gracefully. But in Erlang, they realize that there's almost infinite permutations in which this can happen. So the only state you can bring your application back to, in which you're guaranteed to have a good state, is when you initially started it. So why not just let it die and then just restart it, so you're back at that clean state again? So even like right here, we can see that with the process. Even if I try to call it, the PID is undefined now. The process is gone. It's no longer available. So with the supervisors, this is looks like a child's drawing, but this was made by an adult. The website learnusomeerlang.com. It's kind of like a funny website for learning Erlang, but the idea here is that you have all the green are supervisors and all the blues or purples, I'm colorblind, I can't tell the difference, but are workers. So the idea you have a supervisor that's either watching other supervisors or watching workers, and that supervisor watches other supervisors and workers. So you have this infinite depth tree, potentially infinite depth tree. And so if a worker dies, then the supervisor watching it is notified, and the supervisor can decide what it wants to do with that worker. Does it want to reboot that worker? Does it just want to keep it dead? Or should it go back up the tree further? If you're rebooting the worker, there are different strategies in which you can reboot the worker. Do we just reboot that one worker? Do we look at all the worker siblings and kill those off and then reboot everything at once to put everything within the sibling processes back into a clean state? So these are all different options you have for working with supervisors in Elixir. I worked on it so hard I had to put it in twice. Okay, so to define a supervisor, looks a little bit similar to the GenServer. So we're going to use supervisor, we're going to have the start link on this. The difference here is this init function gets called after the supervisor starts, after the start link. So start link gets called, it passes in this state, that was the last argument on that. And then I'm creating this list called children, which is just the supervisor's child processes that's monitoring. You get this worker function from the supervisor module above, and I am passing as the first argument our stack that I previously defined, and then it looks a little bit, I don't know if you really follow what's going on there, but there's a list with 2 arguments in it. The first argument is going to be the state that we're going to start our GenServer with. The second argument is the options that we had just a default empty list for previously. The reason for that is because the worker is starting within the context of the supervisor now, we don't get access to the PID. And so we have to give it some sort of unique name that we can identify it on so that we can reference it. So in this case, we're passing it the name option, and we're just calling it my stack. And then we call supervise, and we give it the children list. And the strategy here is 1-for-1. You can look up, there's a whole really good documentation on Elixir on what all the strategies mean. Okay, so if we were to start our supervisor now, again, it looks similar to when we started our GenServer. We get back to PID. We don't really need it. You can, if you're using it within another system, you can hold on to it, but for the purposes of this, we're not using it again. Anyway, so now we're calling the GenServer. We're calling cast. So again, we're making that a fire and forget request to the GenServer to push in the hello value onto the stack. But instead of referencing the PID, we're going to reference the unique identifier for it, which was my stack. So we go back, okay. And now we're going to call PID, we're going to call pop, we get back hello, that's great. Now we're going to call that same function, that same one from before that caused it to die, and uh-oh, it died. But the supervisor restarts it. Oh, I think I actually had that on there twice. I meant to have the death on the other screen, sorry. Oh, now I have to go through all my steps again. Okay, so this is when we kill it, right here. But this time instead, and that should be, sorry, that's a syntax error. That shouldn't say PID, that should say my stack. Both of those should say my stack. That's a copy paste error. So GenServer.cast my stack. What we find is that the supervisor saw that that its worker died and then automatically started it. Whereas previously, if you recall back in the previous slides, that when I tried to push a new item onto the stack through the GenServer, it was no longer able to do so because it was no longer available. The process had died out. The difference here, though, is one thing to be aware of is that it will reboot itself with its previous state, with the state in which the supervisor is defined as. There are strategies for getting around that, and there's the concept of an agent within Elixir. Basically, when you instantiate your GenServer, you can have it. You can push all those values into an agent which live outside the GenServer, and then if the GenServer dies, you can repopulate its state from the agent. Okay, so this last part is more opinion-based than it's more subjective than objective, but it's one thing that I've experienced as an Elixir developer over the past few years, and it's something that I've thought a lot about, and what type of impact this means to engineering teams. And the question I pose is, can a language make you happy? And when I first got into Ruby, one of the kind of core tenets of Ruby was that Ruby makes you happy. It was a language that was written to do away with this idea that the engineer had to be the slave to the computer, and the computer should be doing the work for us. So we had this nice, beautiful-looking language. But it, as we indicated, has its own limitations. So with Elixir, I found that it actually took that argument a bit farther. And the reason for that is, some of the stuff that object-oriented programming brings in, OOP. And here's the kind of classical OOP structure, and this idea that, it's just objects, and we have inheritance, and we have objects that inherit from other objects. It's so clean, it makes so much sense. But how many people have seen this in a book, and then a year or two from now, this is what they really got, right? They had something like this, and it's absolutely a nightmare. It happens to everybody, and that's because OOP gives you a lot of rope. And this is true of any language, and it's kind of like my argument against JavaScript in general, is that it gives you too much flexibility, and limitations are actually better. There's power in limiting yourself in what you can do. One of the kind of, I don't know if everyone can see that, but the basic idea here is that, as programmers, we sit there and we, if we have at least an hour to ourselves, we can build up this amazing state in our head on exactly what's going on, and then, once we get interrupted, it's gone, right? And so that, to me, that ends up being the big problem of object-oriented programming is state. So you have these objects that are carrying state around. They're not immediately accessible. They're buried in the memory somewhere. Whereas functional programming is right there in your face. The idea of data in, data out, you do not have in a classical pure functioning programming language. You should not be able to access anything outside of the given function that you're currently in. Now, Elixir and Erlang does violate this a bit through its process message passing, so it's not 100% pure, but within its own process, it's completely pure. I think. I had someone correct me before on the message passing thing, so if someone wants to correct me on the completely pure within the process, I'd appreciate it. But Elixir being a functional programming language, this has a huge advantage, not over just your ability to learn it quickly. We took existing Rails engineers and we gave them the Programming Elixir book by Dave Thomas, which is published by Pragmatic Programmers. If you're interested in Elixir, I highly suggest that you read it. The first part of it was about 200 pages and introduced kind of the ideas of functional programming, the syntax. Within a week, this is no joke, within a week they were making contributions back to a Phoenix application. That's not to say that they were expert Elixir engineers within a week, not to say that they learned all of the nuances of distributed programming within a week, but just that the idea of functional programming, it ends up being very, very simple and very, very easy to learn. The reason why, in part, why functional programming perhaps is taking a while to catch on, now like you're seeing a lot of articles on functional programming, due in part to memory limitations, right? So you're not passing in values by reference within functional programming. You're passing everything by value. And so that ends up being memory copies and memory allocation. Nowadays, memory is fairly cheap, and so this is less of a concern, but back when you had 16 megabytes of RAM, yeah, that was concerning, that was difficult. So you could see the value of an object-oriented language that was mutating memory on the fly back then. But today, the value is really not there for that, or at least the argument for that is not there. All right, so anyway, I will stop rambling because I think I'm getting close to time. I will just say, go learn use from Elixir. It's an awesome language, and just to pimp myself again, CEO of DockYard, we're based in Boston. We do Phoenix Framework Consulting, Elixir, and also Emergis Consulting. And you can find us at DockYard.com. So thank you very much.
Does Elixir support protocol-oriented programming in the class structure?
So there are no classes in Elixir. There's modules, it's just namespace. But what do you mean by protocol?
Protocol-oriented programming in terms of when you attempt to write a class structure and you have to extend it, and based upon pattern matching.
So there is an idea of, it's not really so much inheritance within Elixir. It's more like, or class extensions. You have modules, and you can actually have those modules define compile time functions that will emit Erlang AST. And so when you do use GenServer, there's a compile time function within the GenServer module that will emit the AST code that gets injected into the module that you're using it in. So yes, there is a way to reuse code. But it's not through a more like classical, like class extension style. But it's done in such a way that it pushes all the work to build time.
Okay, thanks everyone, and don't forget to rate in the app. Have a great day.